Good morning, sir. My name is Monica. My topic is about resistors. Resistor theory is based on the fundamental principle of resistance, which opposes the flow of electric current according to Ohm's law, expressed as V equals to IR. A resistor is a passive component that introduces this opposition in a circuit to control, limit, or divide current and voltage. Resistance is measured in ohms and is a function of the material's resistivity and its physical dimensions. Types of resistors: buffer resistor, controlled buffer resistor, shift right resistor, shift left resistor, bidirectional shift resistor, system in signal output resistor, series in series output resistor, series in parallel output resistor, parallel in series output resistor, parallel in parallel out resistor, universal shift resistor. Introduction: a resistor is a small high-speed storage location inside the central processing unit. It is used to store data temporarily during the execution of instructions. Registers are faster than cake and main memory RAM because they are located directionally inside the processor. Buffer resistor. A buffer resistor is a temporary storage register used to hold data while it is being transferred between 2 and 1 by 0 devices or CPU and memory. It acts as a bridge between devices that operate at different speeds, ensuring smooth and efficient data transfer. Controlled buffer resistor. A controlled buffer resistor is a temporary storage resistor that holds data being transferred and control and the direction, timing, and enabling of data flowing using control signals from the control unit. Shift right resistor. A shift right resistor is a type of shift resistor where the binary data bits are shifted one position to the right on each clock pulse. Each flip-flop stores one bit, and the bit in one stage moves to the next stage on the right. Shift left resistor. A shift left resistor is a resistor that moves all the stored bits one position to the left on each clock pulse. The 2-bit enters from the right and the leftmost bit is shifted out. All flip-flops share a common clock signal. The output of each flip-flop is connected to the input of the flip-flop. Its left. The serial input line provides the new bit that enters on the rightmost flip-flop. Bidirectional shift resistor. A bidirectional shift resistor is an advanced type of shift resistor that allows binary data to be shifted both to the left and the right depending on the control signal. It is a sequential logic circuit made up of flip-flops and additional logic gates to control the direction of data flow. Series in, series out resistor. A SISO resistor is the simplest form of the shift resistor. It accepts data serially, one bit at a time, and outputs data serially as well, hence the name serial in, serial out. It is mainly used for temporary data storage time, delay generation, and serial data transmission. Serial input parallel output resistor. A serial input parallel output resistor is a type of shift resistor where data is entered serially, one bit at a time, but made available in parallel form at the output. This means it converts serial data parallel data, making it very useful in communication systems, microprocessors. Parallel in series output resistor. A parallel in serial output resistor is a type of shift resistor that allows parallel loading of data and then serial shifting of the data out of the resistor, one bit at a time. It is the reverse of SI-PO resistor and is widely used in data transmission systems where parallel data must be sent serially from a microprocessor of a serial communication unit. Parallel in parallel output resistor. A parallel in parallel out resistor is the simplest, fastest type of shift resistor. It allows parallel loading of data and parallel reading of data, meaning all bits enter and exist simultaneously on a single click pulse. Key concepts of resistance: the property of a material that opposes the flow of electric current, it measured in ohms. Universal shift resistor. Universal shift resistor is the most versatile type of shift resistor because it can perform all possible operations. It can shift data left, shift data right, load data in parallel, and hold data. It combines the features of bidirectional and unidirectional shift resistors, enabling versatile data manipulation, shift left, shift right, parallel load, and hold. Key concepts of resistors. Resistance, the property of a material that opposes the flow of electric current. It is measured in ohms. Ohm's law, the relation between voltage, current, and resistance in a circuit. V equals to I into R. This law states that the current through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Voltage drop. When current flows through a resistor, there is a voltage drop across it, also known as the IR drop. Power dissipation. Resistors dissipate electrical energy as heat. The amount of power a resistor can dissipate without damage is its power rating, which is related to its physical size. Types. Resistors can be fixed with a constant resistance value or variable where the resistance can be changed. Kirchhoff's law. These fundamental circuit laws, along with Ohm's law, are used to solve complex networks. Kirchhoff's current law. The sum of currents entering a node is equal to the sum of currents leaving it. Kirchhoff voltage law. The sum of voltage drops and rises in any closed loop of a circuit 0. How resistors are used. Current limiting prevents excessive current from damaging other components. Voltage division splits a larger voltage into smaller desired voltages. Setting the constants used the capacitors to determine the charging or discharging time of a circuit. Setting circuit gains can be used to the set gain of an amplifier circuit. Signal filtering. In AC circuits, resistors are used to filter signals. Resistor types, color codes, formulas, and circuits. Resistors connected in series. Introduction to circuit theory. Electrical science of principle. Resistor. In electronic circuit, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmissions. Resistor connected in series, they are resistors and resistance. Key concepts of resistance. The property of a material that opposes the flow of electric current. It measured in ohms. Ohm's law. The relationship between voltage V, current I, and resistance R in a circuit. V equals to I into R. This law states that the current through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. Voltage drop. When current flows through a resistor, there is a voltage drop across it, also known as the IR drop. Power dissipation. Resistors display electrical energy as heat. The amount of power a resistor can dissipate without damage is its power rating, which is related to its physical size. Types of resistors. Resistors can be fixed with a constant resistance value or variable where the resistance can be changed. Kirchhoff's law. These fundamental circuit laws, along with Ohm's law, are used to solve complex networks. Kirchhoff current law. The sum of currents entering a node is equal to the sum of currents leaving it. Kirchhoff's voltage law. The sum of voltage drops and rises in any closed loop of a circuit is 0. Thank you, sir.